In this particular section of video, we are going to understand a special type of series. See, when I say special type of series, we are trying to look at particular known things. Okay, for example, known things in the sense known sum. The first one is sigma n. Sigma n is 1 plus 2 plus 3 till n, which is n into n plus 1 by 2, which we all know. Okay. Next is sigma n square. Sigma n square is n into n plus 1 into 2n plus 1 divided by 6. Next we have sigma n cube. Sigma n cube is, if you look at it, n into n plus 1 by 2 the whole square, which is n square into n plus 1 whole square divided by 4. Now, considering these three as the base formulae, now what we are going to do is we are going to solve few problems. Alright. Now let's look at it. Look at the first one. See, the first one, what we have, 1 into 2 into 3 plus 2 into 3 into 4, so on and so forth. Now in these kind of problems, first what you guys need to do is that try to find a pattern in this particular problem. See, when I say a pattern, look at this one. What you have is 1, 2, 3, 2, 3, 4, correct? Or in other words, what you can say is that n into n plus 1 into n plus 2, correct? Since we know the pattern, the nth term we can calculate. That means, see, in this one, the nth term is going to be Tn is equal to n into n plus 1 into n plus 2. Now multiply. If you do that, you'll get n square plus n into n plus 2. Multiply n cube plus 2n square plus n square, 3n square plus 2n. See, this is the nth term of the sequence. Alright. Now what we need is sigma Tn, because that's going to give us the sum to n terms of this particular sequence. Correct? So when you sum it up, or when you apply that summation, we are going to get sigma n cube plus 3 times sigma n square plus 2 times sigma n, correct? Or n into n plus 1 by 2 whole square, 3 into n plus 1 into 2n plus 1 divided by 6 plus 2 into n plus 1 divided by 2. So this is what we have. Before we go further, let's try to take up few things common. We can cancel a few things. We can do a lot of simplification. The first part, if you square it, you're going to have n square into n plus 1 whole square divided by 4 plus 3 into n plus 1 into 2n plus 1 divided by 6 n into n plus 1. Alright. Now we can take n into n plus 1 as common. Alright. See, if you take that, then you are going to get n into n plus 1 into n into n plus 1 divided by 4 plus, here we can take this as 2, correct? 2n plus 1 divided by 2 plus 1. Taking 4 as the LCM, you get n into n plus 1 divided by 4. So this is a 1. N into n plus 1 plus 2 into 2n plus 1 plus 4. Isn't it? Or let's try to do it here itself. N into n plus 1 divided by 4 into n square. See, here we are going to get 4n, and this is going to be n, which is a 5n. So n square plus 5n, correct? Plus 2 plus 4 is 6, which you can further split as n plus 3 into n plus 2. correct? Final answer is going to be Sn is equal to n into n plus 1 into n plus 2 into n plus 3 whole divided by 4. So this is going to be the final answer for the first question. Clear? And this is how you need to do it. Fine. Let's solve the second one. See the second one. 5 square, 6 square, 7 square, all the way till 20 square. Correct? Now, if you look at it, see, when you take 1 square, 2 square, 3 square, in the beginning you saw the formula, it is sigma n square. But here we have 5 square, 6 square till 20 square. What we need to do is we need to find the nth term, or you can say the general term, correct? So we can say that the nth term is going to be n plus 4 whole square. Put n as 1, 2, 3, 4, you're going to get this particular sequence, isn't it? So nth term is this, which is nothing but n square plus 8n plus 16. Now we need to take sigma of this one. That is Sn is equal to sigma n square plus 8 into sigma n plus 16. There is no n term, so there is no sigma n. Correct? If you have n, only then you will be able to write sigma. Otherwise, there is no point in writing sigma. So in this case, sigma n square n into n plus 1 into 2n plus 1 divided by 6 plus 8 into n plus 1 divided by 2 plus 16. Correct? 4. That's all you can do. Now you can take n into n plus 1, n into n plus 1 into 2n plus 1 by 6 plus 4n into n plus 1 plus 16. See, this is summation, or you can say the sum to n terms for this particular progression. But are they asking for sum to n terms? No, right? We have till 20 square. That means, what value do I put for n so that I get 20 square as the last term? Look at it. Think about it. See, my nth term is given by n plus 4 whole square. What term do you put for n? What value do you put for n? N has to be 16 because 16 plus 4 is 20. Put that. So you're going to get the 16th term is going to be 20 square. Correct? So everywhere in the formula, put n as 16. Make sense? We are just substituting the n value. That's it. Now this is going to become 16 into 17 into 33 divided by 6 plus 4 into 16, 64 into 17 plus 16. Correct? So here, if you do this one, so 2 3 times 2 8 times, this is going to be 11. Now once you solve, you're going to get an answer 2840. This is going to be the final answer. That means for the second one, it's not a variable related problem, it's a number related problem. So the answer is given to be this one. Clear? Let's do the third question now. The third question. See what do you have in the third one? You have 3 into 8, 6 into 11, 9 into 14. Guys, look at the pattern. Try to understand the pattern here. You have 3, 6, 9. Next one is going to be 12. That means my nth term has to be a multiple of 3, 3n. Correct? And what is the next one? 8, 11, 14. That means 3 plus 5 is 8. 6 plus 5 is 11. 9 plus 5 is 14. So this is going to be 3n plus 5. Isn't it? So what do we get? 3n into 3n plus 5. So the whole point of these problems are You just have to figure out what is the nth term. If you know the nth term, then solving is very, very simple, correct? So 3n into 3n plus 5. Multiply 9n square plus 15n, right? So Sn is equal to 9 into sigma n square plus 15 into sigma n. Or this is going to be 9 into n plus 1 into 2n plus 1 divided by 6 plus 15 into n plus 1 divided by 2, right? 3 2 times, 3 3 times. Now you can take n into n plus 1 as common, or you can also take n into n plus 1 by 2 as common, which makes more sense, right? If you're if you're okay with doing couple of things, then you can actually take 3n into n plus 1 by 2 as common, to be honest with you. But let's take things much easier. No problem, no issues. So what we'll do, we'll take n into n plus 1 divided by 2 as common into 3 into 2n plus 1 plus 15, right? So we are going to have n into n plus 1 divided by 2 into 6n plus 3 plus 15, correct? Now 6n plus 15 is nothing but 6n plus 18. So we are going to have n into n plus 1, n into n plus 1 divided by 2 into 6n plus 18. I'm sure all of you understood what number you can take common. 6 you can take common, correct? So n into n plus 1 divided by 2 into 6 into n plus 3. Cancel. So what do we get as the final answer? 3n into n plus 1 into n plus 3. This is going to be the final answer, or you can say the sum to n terms for this particular progression. Fair enough? Now let's do the fourth one. You have n into n plus 1 into n plus 4. See, nth term is already given to you. What do? Multiply, and then directly you can just start with the summation, right? So here for the fourth one, multiply. Nth term is going to become n square plus n into n plus 4, which is n cube plus 5n square plus 4n, right? So now Sn is going to be sigma n cube plus 5 times sigma n square plus 4 times sigma n, correct? Now this is going to be n into n plus 1 divided by 2 whole square plus 5 into n plus 1 into 2n plus 1 divided by 6 plus 4 into n plus 1 divided by 2, right? So this is twice, nothing else you can take common. But, sorry, nothing else you can cancel out, but you can take common. N into n plus 1, you can take common everywhere, isn't it? That means this is going to be n into n plus 1 into n plus 1 divided by 4, 5 by 6 into 2n plus 1 plus 2, correct? Now we need to take LCM and solve this one. So you are going to have n into n plus 1 between 4 and 6, 12 is the LCM, divided by 12 into 3n into n plus 1 plus 10 into 2n plus 1 plus 24. Okay. n into n plus 1 divided by 12 into 3n square. Now you're going to get 3n plus 20, 23n. Next you're going to have 10 plus 24, 34. Okay. Able to split this one, like, you can't split and factorize it. So what do we write? So we are going to write the final answer as Sn is equal to n into n plus 1 into 3n square plus 23n plus 34 whole over 12. This is going to be the final answer for the fourth one. Now let's do the last one. N square plus 2 power n, correct? So nth term is n square plus 2 power n. So you have Sn is equal to sigma n square plus sigma 2 power n square. N into n plus 1 into 2n plus 1 divided by 6. See, sigma 2 power n is nothing but 2 power 1 plus 2 square plus 2 cube till 2 to the power of n. Isn't it GP? Correct? What is the sum to n term of a GP? There are two formulas. In this one, which one are you going to use? The first one, in the sense where r is greater than 1. Correct? So since r is greater than 1, which formula are we going to use? We can use a into r power n minus 1. Correct? So r power n basically 2 to 2 power n minus 1 divided by 2 minus 1. Isn't it? So we are going to have n into n plus 1 into 2n plus 1 divided by 6 plus 2 into 2 power n minus 1. You can't simplify, you can't do anything for this, isn't it? So this is the answer for the fifth one. Alright, so in the next video, we are going to look into the summary of what you have learned in this particular chapter.